Okay, so here's what we're doing today. Um, we're going to delve deeper into linear equations, um, and we're going to use the astronaut piece around it. So we're going to use Desmos to do it. After we go through a brief little lesson piece, um, then um, we will basically work through Desmos pretty much the whole time. Are we doing word problems still? Not to, well, that's kind, you know what? It's kind of both. We're basically working on one problem all the way through, and um, and it, it's like a word problem in that we're going to be. It's like real world stuff, in which we'll be pulling stuff out of it, and we'll see how we work it through. So it's really kind of one problem the whole time is what we're working on. Okay. Um, so one thing I did this weekend, which is kind of similar to the space part, um, and no, the Desmos part isn't your homework. We have about 5 problems after that, but after doing this problem, I think that your homework's going to be pretty simple for you guys. But I could be wrong too. I mean, I may not explain it very well, so um, we'll see how it goes. So this weekend, I saw a piece of it close to the end of the movie of The Martian. Have any of you guys seen that movie before? It's got Matt Damon and Jessica Chastain and um, Griffin has. Anybody else? Yeah. So basically, the movie is this: there's a space crew that goes and they land and they are spending time on the planet Mars, and um, NASA communicates with them and says, "We're seeing that there's going to be a meteor shower, something like that." And if I'm wrong, Griffin or Sam, just let me know. Um, and they want them to evacuate the planet. Well, Matt Damon is a botanist that is on the planet, and he's out doing some readings, and he gets knocked out, knocked unconscious, and they can't reach him. They can't do it, and they're coming down to the wire. They've got to say go or no go, no go or no go, and they can't reach him. So they figure he's died, and and so they leave without him. And after they leave, he comes back to consciousness, and they kind of find out the the crew's going to come back for him. Okay, and anyways, um, and Mr. Warhols just shared it with us here. Um, what it kind of looks like. So this is Hollywood's rendition of the red planet of Mars. And so anyways, he's got to survive on his own. And he comes up with all these ways. And one of the things that he finds is the commander left her playlist behind, her music. And so my first question is, if you had to go to Mars or to the moon or to the space station, or anything like that, and you had one song that you would absolutely have to take with you, what song would it be? What tune? I'll share mine, and mine would be one of three, and I probably have to include all these three. Um, for me, for me, Bruce Springsteen, "Born to Run" would be one of them. I know these are old school, but that's me. Another would be um, U2 live, um, "Where the Streets Have No Name," and Coldplay, "Up and Up." Same thing live. I like the live version of it. Okay, so we've got some in here. "Dark on Me," Royals, "Jingle Bells." Anyone else?
Take Five by Miles Davis.
"Take Five" by Miles Davis. Oh, I'm gonna have to look for that one. I haven't. I'm not. I've probably heard it, but Don't know about Miles Davis. All right. She's Gone by Hall and Oates. Yeah. Yeah. That's a good old school one too. I listened to that a few times. Anybody got any others? You can send it to me. You don't have to send it to everyone. And I won't, if you're uncomfortable with sharing what your music is. I'm kind of worried about sending mine as well. Lose control.
What if you only had an album? Like not just one song, but an album.
You can do an album. I'll go with that.
Can you do an artist?
You could. We've got some Beatles songs. Yeah. All right. So, and if you guys are familiar with Guardians of the Galaxy, of course, he's got a playlist on there too. Chris Pine's character. So, just thought it'd be kind of interesting to see what you guys would think about, would want to take.
Wait, wasn't it Chris Pratt?
Yes, Chris Pratt. Sorry, Chris Pratt. Thank you. There's so many Chris's now. I get them mixed up. So anyways, today, like I said, we're gonna be working in Desmos after a short, brief instructional piece. And so let me share my screen. So like I said, we're talking about linear equations. And at the end, we want you to be able to say, I can explain how to create a point using a point slope equation, and I can accurately use a point slope equation. Okay, so questions you may have. What is the point slope form? Mr. Warhol's shared it with his icon. If you want to see his, look at his screen really quick. And then in the meantime, I will write it down. Okay, so the formula goes y minus y sub 1 is equal to m times x minus x sub 1, where xy and x sub 1, y sub 1 are points on the graph, and m is equal to the slope. Okay, that may not be so easy to read either, so I won't use that red so much. And that's not really very easy either. There we go. That might be a little bit better. Okay, so y minus y sub 1 is equal to m times x minus x sub 1. X and y are points on the graph, and x sub 1 and y sub 1 are points on the graph. Okay, so Mr. McGibbon, so what? All right, so let's piece it together a little bit. If I were to say this, y minus 12 is equal to 4/9 times x plus 7, then we know that one of the points, because remember, this is y minus y sub 1 and x minus x sub 1, that one of the points would be -7, and 12. So one question might be coming up right away. Mr. McGibbon, why is it -7? Oh, because remember in our multiplication piece, minus a minus is equal to a plus. Okay, and then we would also know that in that above equation that the slope would be equal to 4/9, which we got from there. Okay, so we have x sub 1 and y sub 1 and the slope. Okay, question so far? Just doing check to make sure that I want to make sure you guys are on right on with this. So what's the 12? So the 12 comes out of, remember, y minus y sub 1, so y minus 12, so that's still 12 from there. Okay? The x minus x sub 1, well, x minus -7 is the same as x plus 7. I'm just being tricky in advance, so that's where the -7 goes. So, go ahead.
Yeah, sorry, but I'm still kind of confused about why the 7 goes into like the X slot and like why not the 12?
You know what? That's, yes, easy to confuse because look at both. We would think that maybe it might make sense for one side, the other side, right? We might make that might make sense, and so that's something that we really have to be careful about. That while the x's are here in the formula, the x coordinates are always the first one on the left, aren't they? Okay, is that kind of what you were asking, Ethan? Sorry, if you replied, it was, you're on mute. Okay, so let's try this. If we had this point on the graph, if we had 3 and 8, okay, and we had a slope of -2, m is equal to -2. And I'm just going to write our equation in here again, is equal to m times x minus x sub 1. So y minus is equal to times x minus. So who can help me fill out the blanks here? Who can help me with what should I plug in for m? That's pretty simple, isn't it? So that the slope or the rate of change is -2. Okay. What about the other y value? What am I going to plug in here?
Eight.
Yeah, y minus 8. Thank you, Cheyenne. Yes, and what about for my x value?
3.
3.
Yeah. Okay. So we could do that. And then, you know what? We could even create a table if we wanted to. So if I had my x here, my y here, we know that one point is 3 and 8. So if my equation then is y minus 8 is equal to -2 times x minus 3. Okay. Do you think that there's any way that we could get another y value by plugging something in on this? Any ideas? There's our formula. Can I use that to help populate the table? Yes, no, or maybe?
Yes.
Okay, we've got one yes.
Maybe.
Oh, we got a maybe. Okay, not ready to commit yet.
Maybe.
Maybes? Oh, we're all gonna go maybes here. Prove it to us, Mr. McGibbon. That's what you're saying. Okay, let's just do this. I'm gonna plug in 0 and let's see if it works. So we don't know what our y is yet. So y minus 8 is equal to -2 times 0 minus 3. Okay, we'll still have y minus 8 is equal to, what's -2 times 0?
Yeah.
Thank you. And -2 times -3?
6.
Plus 6. Okay, so that's y minus, minus 8 is equal to 6. Add 8 to each side. And we get y is equal to, what's that looking like, 14? Let's see if this makes sense, because while this is going up, this is going down. Okay, does that make sense with what our slope is? What's our slope, positive or negative?
Negative.
Okay, so does that make sense that this would go down? The y's will go down as the
Yeah.
x's went up? Okay, how about this? Just to do, let's see if I multiply the difference between these two by my slope, if I get the difference here. So -2 times, that's a difference of 3, right? So if I just did a quick calculation, -2 times 3, is that the same as, that's -6? And what does this go down? -6? Yeah, that makes sense. So what would you say now? Yes, no, or maybe? Did I convince the maybes?
Yes.
All right. Okay. And what did I do here? Somebody tell me what I did. Somebody tell me what I did to populate the y value in the table. How did I find this y?
You substituted for x.
Okay, I put x value in there. Does it matter which x value?
No.
No. Anybody else want to help? No, it doesn't matter. Of course not. We can plug anything into x. What if I did it? What if I had it this way? What if I had, I'm just going to say 4. Could I do the same thing and find my x, do you think?
Yes.
Yes.
What would I do? You guys say yes. What would I do? Given my point slope.
You would substitute the y for 4.
Oh, so I would go 4 minus 8 is equal to -2 times x minus 3. And then I would be solving for what? Instead of y, I'd be solving for my x. And whatever I got for my x is what I'd plug in there. Okay. Do you want me to try it really quick to show everybody?
Yes, please.
Okay, let's do it then. Okay, so I'm going to do this one in purple, and if it doesn't show up right, then I'll change it. We have y minus 8 is equal to, wait, let's come down a little. Y minus 8 is equal to -2 times x minus 3. Okay, and we're plugging in the 4 from here into our y. So that's 4 minus 8 is equal to -2 times x minus 3. The reason why this is still an x is because we don't know yet. We're trying to find it, right? Okay, so -4 is equal to -2x plus 6, is that? Okay. Let's subtract 6 from each side. And that's going to give us negative 10 is equal to negative 2 x. What's x going to be in that case?
5.
5.
Yep. Does that make sense? So we went up 2 here times negative 2. And so should we go down 4 here? That's right.
That makes sense.
Starting to make sense?
Mhm.
Man, I'm rolling here. Let's take advantage of that. I am going to paste in our Desmos piece. So we're going to pretend that you're the commanding officer on the space station and you sent Terry Virts, our astronaut, out on a spacewalk. So I want you to watch his video feed and monitor his vitals while he works. There will be a screen that shows up there. Those are the actual vitals that it's showing. Okay. So I'm going to just share it here. And this is an actual spacewalk. Let's come back to Zoom. I'm going to share my screen. Let's see if we can just go through this just a little bit. We're a little bit stuck, which is a good thing. Okay, so come back to Zoom, please, and let's see if we can go over this really quick. Let's see. Oh, that one. Okay. Hang on a second. So Griffin, can you help me with just a little bit of this here?
Yeah.
Okay. If we have our, what do we have that helps us here? I wrote down what we had other than the heart rate. Okay, I didn't put that down yet because I don't know if that makes anything or not. But so it looks like we need to find out what our Y value is, and this is O2 left, and this is ours, right? Okay. So we need to find out at the beginning, what's this Y value going to be? Can somebody tell me what this is going to be? Not the number, but the label. What would we say that this is at the beginning? How much what?
PSI.
How much PSI what?
How much to start off with?
Yeah, they started with. Start. And then what's this? This 0.
When they're done.
Yeah, when it's empty, isn't it? Okay. So empty. That's what it's asking us for. So what is this right here? Griffin, what's this? The average rate of use.
It's the, wait, what are you asking? Like,
So what is this? This number here.
it's how much he did use per hour.
Okay, so per hour.
average.
All right, so I'm just going to write it again. 17.594 use per hour. Can somebody tell me, is this going to add or subtract every time?
Subtract.
Oh, so
Technically add and subtract because you have to fill in the first Y value and then the last X value.
maybe, but when we use it, are we depleting the oxygen or are we adding the oxygen?
We're subtracting, we're depleting it.
Okay, so it's going down. And I want you to make sure that we we keep that in mind because, hey, I missed that early. Okay, so we've got this information. So Griffin, what kind of a formula can I use to come up with it?
You can do y minus y equals m times x minus x.
Okay, we can use our point slope. Do you have any idea of what we could fill in here?
Yeah, we can fill in the second y as 853.609.
Okay, y minus 853.609 is equal to what?
The slope, which is negative 19.594. So the slope would be
17.954, right?
Yeah,
Sorry,
yeah, yeah.
my writing is sloppy there. 17.594. Okay. And then what's the rest of it look like?
x minus 1.5.
X minus 1.5. And what's the 1.5 again?
That's how long his spacewalk has been.
So far? Okay. So can you guys, seeing this, do you think you can complete the table now?
Yes.
Yes? All right, go back and do it. See what you can figure out for me. If you're stuck again, then send it to me in the chat.